Hello everyone, my name is Kuldeep Kumar and I am a mechatronics engineering undergraduate student. Today I am going to present and explain my project. My project title goes like this: DC motor angle control system using servo meter and feedback. So let's see how project objectives are. So the main goal of this project is to design a system that can control the angular position of a servo motor accurately based on user input and verify the actual position using the real-time feedback. So let's see how the angle importance of angle control. So precise angle control is a key requirement in various applications, like as we all know, that such as robotic arms, antenna positioning, industrial automation, and home automation. In this project, I have developed a simple yet reliable angle control setup using basic electronic components. So now let's get into directly the components. What are the components used in our project? So the major components involved in this project are an Arduino Nano microcontroller, hobby servo meter with 180-degree rotation capability, a potentiometer for setting the target angle as shown in the video, a rotary encode for feedback on actual positioning, an LCD display with I2C module for showing angles, and a 5 voltage adapter for a stable power supply. So let's see like how this project works. So let's directly get into the working principle. So it's very simple, it's very easy. The working principle is the user rotates a potentiometer to set the desired angles. The Arduino reads the analog input and maps it to a range between 0 to 180 degrees. So based on this, Arduino sends a control signal to the servo meter. As the servo meter moves, a rotary encode attached to its shaft measures the actual angular position. See how the other things are included. So the Arduino compares the target angle and the actual angle, and the displays both on the LCD and real time. So now let's see system connection, overall the system, how it is connected. So the servo signal wire is connected to digital pin D9 of Arduino. The potentiometer middle pin is connected to analog pin A0. Okay, so the rotary encoders CLK and DT pins are connected to D2 and D4, which are interrupt capable pins. So the LCD uses I2C communication and is connected to A4 and A5 pins. So let's see how the code works. So the code explanation goes like this. The potentiometer input continuously reads the code and updates the servo meter position accordingly. An interrupt service routine reads the encoder pulses and calculates the actual motor signal. Whenever there is a change, the LCD is updated to show both the target and actual angles. So we have got the observations as well. So when we test, so how it will show a display. So during testing, when we rotated the potentiometer, the servo motor responded smoothly to the changes, and the LCD displayed both the input and output angles accurately. The encoder feedback showed that the actual angles closely matched the set angles with minor deviations due to mechanical tolerances and slight servometer backlash, which is acceptable in non-critical applications. So now let's see how applicable, how this project is applicable. What are the applications? So the applications of this project goes like this. This servo control system can be adopted for several real world applications. So let's see what are those applications in robotic arms, where video it's an absolute pleasure to describe this